Welcome to the ET322 how-to video for the Thyristor Lab. I'm having some problems getting this one work, so let's go ahead and put a switch in, because these devices, once you power them up, they can turn on, and I need a way to reset everything in order for us to get this to work. Okay, good. So let's go ahead and put a couple probes in to measure our voltages. Let's go ahead and move this all up. There we go. And let's stick our probe in, because we need to know what our voltage is on our SCR. Good. Okay, let's test our circuit here. Let's go ahead and make sure our LED is off. It is. So let's close A, and let's go ahead and close our space once we move our pot all the way to 100%. So let's close it, and let's start moving our potentiometer in here, and we're going to check to see what voltage our SCR takes at the gate to turn it on. And right there, and it's about 824 millivolts. Right here, our SCR from our anode to our cathode is 11.4 millivolts. Essentially, it's a closed circuit. That's why our LED is on. Okay, let's open up our switch, and once our SCR is turned on and we remove our switch, the LED should stay on. So this SCR is triggered on and will remain on until we do something to turn it off. Let's go ahead and zoom in a bit. Okay, let's fire it up. And all right, so our LED is on, and if we close key E, it should, okay, let's go ahead and open up switch 1, which would be the space. LED is on. If we want to turn it off, let's go ahead and hit E, and it should turn it off, and it does. Okay, here we're back at our variable phase control circuit. Let's go ahead and change our potentiometer until we get the LED flashing. And we'll show you, okay, this here's our firing angle. So let's go ahead and see what our minimum firing angle is. We're going to go the other way, sorry. Till we lose it, and that would be the minimum, and it's right there. So let's go back up one. Here we go. So that would be the minimum firing angle here in order to keep our LED. So let's go ahead and do a single shot, and let's go ahead and see if we could take a closer look at this. Okay, here's our waveform. This is kind of ugly here, but anyway, essentially what we're doing is, since we have the diode and our SCR, right here is our firing angle. That's the minimum in order for this LED to light. And I could go ahead and move this the other way until we get most of the sine wave. And this is the minimum though. Let's go ahead and skip part 4, since a motor takes too much power for our multi-sim and doesn't work properly. So let's test our circuit. First thing I did is I reduced these to 500 ohms in order to make our LEDs more realistic. And I've increased the voltage here to 20 volts to make sure that we have enough to fire our crowbar circuit. Okay, so this is a over voltage protection circuit, and let's go ahead and put enough volts on it in order to get the LED to light, and that should be in a normal operating condition. There we go. And about 4.76 right at where our zener is, so that voltage is just right on the ragged edge. Okay, and so our LEDs operating normal. So our crowbar circuit's designed that once the voltage goes high, it exceeds its zener voltage, which fires our SCR and essentially shorts out the power supply. So it's a crowbar, meaning it's a pretty violent action, so it actually blows the fuse. So when this LED, red LED comes on, that means we've exceeded the voltage for the crowbar, and it'll shut everything down. Not in this case because it's parallel, but this one should. There we go. Actually at 20 volts, it fired our SCR and shut down the circuit.